Hello, this is Ms. Lancaster. This is video 7, Where Does the Matter Go? It is important to understand that when matter undergoes a chemical reaction or a chemical change, it does not disappear or suddenly appear. The atoms just get rearranged. Think about how many times you have changed seats. We've still had 28, 29 people in the classroom, but they've gotten rearranged. So the total mass of the class has not changed, just the organization of the matter. Okay? So mass is not gain nor loss, and that's what conservation means. There's no gain, there's no loss, but there's a change, a new use, and in this case, all new compounds are formed. This is called the law of conservation of matter and energy. So, in a chemical reaction, the total atoms of each element are equal on each side of the reaction. Now, some of those atoms are in compound form, some of them may be in single element form or diatomic element form, but the total number of atoms for each element has to be equal on both sides for the equation to meet this law. Now, sometimes equations are written in a hurry and they're not balanced. So somebody has written down, I think of it like a grocery list compared to a recipe. They've written down that they need flour and sugar and eggs and milk to make the cake, but they haven't written down the amounts. And when the equation is balanced, the amounts are accurate. So, some of the chemical reactions you experience would be when the acid in milk and the baking soda is basic and they react, and while a cake is baking, and that chemical reaction produces carbon dioxide gas, and gases rise, and so that causes the cake layers to expand or to rise. When paper burns, it produces ashes, carbon dioxide, and water vapor. When hydrogen peroxide decomposes and breaks down, it produces water and oxygen gas. And if you take zinc, if you remember our pennies and the hydrochloric acid, and it forms zinc chloride, and we collected the new hydrogen gas in a balloon and let it burn. Alright, so now reactions can occur in closed systems or open systems. And in a closed system, that would mean, for example, you put the two chemicals together in a flask and you put a cork in it and everything occurred inside that container. Or you put it in a Ziploc bag and sealed it. So if it is sealed, that's called a closed system. And when the reaction occurs, the beginning mass will always be equal to the mass at the end of the reaction. However, if the system is open, there's no way to contain the gases. We know gases are lightweight and rise, and they don't stay in their containers very well. They can escape out into the atmosphere, and you can't measure that mass once it's mixed in with the air. And that's called in an open system. So the law of conservation says that the reactants, which is what you start with, what is doing the reacting, is always going to equal the mass of the products. Now, you remember our jelly bean pretend elements that we used. I put some of each of them in the bucket balance. Now let's assume they're undergoing a chemical reaction and they form something brand new. They chemically change. Now, all the atoms have to be the same. So right now they're in balance. Equal atoms of each. That's what conservation says.